Thank you, Richard, for the kind introduction. I am tall. Hopefully you can hear me here. My name is Mike Umbro. I'm from San Diego, and I'm your neighbor. We started Californians for Energy and Science last year because we are sick of seeing the retardation of California's energy systems by the political elite that do not have a plan, as we've heard today. We are sick and tired of not having our workers, who we need to speak more about, who are not in this room, the workers that every time I come up to Kern County, it feels like a funeral. And I come up every week. And every week there's people getting laid off. There's businesses struggling. These contractors will not be here for the new DAC hubs. They will not be here for these energy projects if we do not preserve the community that is Kern County. And that is why we are generating a movement with Californians for Energy and Science. You can scan that QR code. I'll speak briefly about what we're doing. That will take you to our landing page where you can click Join Us and sign up. We meet monthly. It's free. It's open to everybody. We've moved it all over the state, from Santa Barbara to Ventura to Bakersfield. We're going everywhere with this message that, yes, the tankers are the #1 source of pollution in the LA basin. We pollute more at the port complex of LA and Long Beach than all 6 million vehicles combined in Southern California. So what good does it do if we transition everything to an EV if we're poisoning the black and brown and the disadvantaged communities that we are quote unquote trying to save through constant imports coming into our communities? And we are independents that do not have the shackles of a corporate structure, and we will say the quiet part out loud, and it's important to do that. And what we're doing is we're studying the environment. We're doing air monitoring studies in our field. And you know what? Preliminary results show there's nothing contaminating these homes around our communities because Kern County has heavy dead oil, whereas the agencies that put together these preliminary reports on the dangers of the oil and gas community in Kern County, what do they use? Marcellus Shale, Permian Basin, high pressure, high gas, totally different reservoir composition than what we're dealing with in Kern County. Why don't they study the fields here? Guess what they do? They're called SNAP studies, and they don't release the results because the results support what we do. That we are not killing our communities, that we are providing jobs for our communities. So what I've been doing, sorry my voice is a little hoarse, but what I've been doing and what we've been doing is going to the universities, because another thing that you see here is all grown adults. Where we need to be is at Taft Oil Tech Academy, where we've been presenting and working with the students. I was just invited last week to lecture at Haas. UC Berkeley had me in to talk about the energy systems of California. And you know what the students said when I brought this message to them? They didn't have an anti-oil stigma. They said, man, thank you. We don't hear this in our lectures. We don't get this information. They know that there is so much more beyond the rhetoric that is a quote-unquote transition. What we're actually experiencing is a renaissance. We're not transitioning away from oil and gas. The CARB scoping plan tells us that. We'll simply have 5 to 7 more tankers bringing finished gasoline into the port instead of making it here. It says that. I think it's page 108. Also, it says that the upstream oil and gas industry is less than 3% of total emissions in California. But we can do better. We should do better, and that's what we're here to talk about. And I love that I was tasked with moderating the Renewable Energy Panel because I'm also a believer in this, and I think what we all need to do, there's a tendency for the oil and gas community and the renewable community to maybe be in competition. And that couldn't be further from the truth because nobody rode a direct air capture machine here today. Hydrostor is not excavating without diesel. SoCal Gas is moving natural gas, and they will move more natural gas than they do hydrogen for the foreseeable future. The hydrogen plane that we're going to hear about needs a tank of Jet A fuel to prove that the hydrogen technology works. Who am I missing? AES. The batteries that AES is going to put out there are not going to be a reality without mining and without cranes to place them in diesel. So we all need to be educating the public about how all of us make Kern County and California work. So with that, I think we have slides for everybody to share first. Okay, universal hydrogen. So this panel is going to be, everybody's going to give a short presentation, 3 minutes, and we'll see what we have time for questions after. So universal hydrogen.
You want me to do it here or over there?
Yeah, no, right there.
Okay.
Yeah.
Okay. Hi, everybody. I'm Arnaud Namer. I'm the COO of Universal Hydrogen. Very happy to meet you. What we do at Universal Hydrogen is we're transitioning aviation to true zero emission. It may seem to you like a far stretch because we're going to hydrogen aviation, but you'll see that actually every technological brick is available now to actually transition aviation to a true zero emission, and it's only a question of will, of good engineering, and of deployment from with regulatory partners. So if we look at the three, so how do we do this? Next slide.
Oh.
Or maybe you can give the clicker.
Yeah. Green button.
Yep, sorry, thank you. So if we look at what's needed to transition aviation to hydrogen, you need clean hydrogen. And I'm very happy to say that Kern County is probably the best location to actually develop that. We'll talk a little bit more about that. You need a hydrogen aircraft, so we need to convert the technology that's inside the aircraft in order to be able to use hydrogen as a fuel. And you need a way to transport that hydrogen from the production site to actually the airplane. So in terms of low carbon hydrogen, it's developing at wide scale all over the planet. And Kern is probably the best location for that because you've got renewable, you've got solar, you've got wind. We're able to develop projects that are behind the meter with a full integration of renewable energy creation, electrolyzer, and liquefaction capability in order to develop the most economical way the clean hydrogen. So thank you to all of our partners. There's a lot that are around these tables for developing these projects because they make California and Kern one of the best locations in the US to be able to develop, and in the world actually, to develop these projects. Then we need an aircraft that actually uses and transforms its fuel to hydrogen. This is a 40-passenger aircraft that we've converted on one side that fully uses hydrogen as a fuel. It's safe. The technology is existing. It's only a question. This is in flying over the Mojave area, so you can see the solar panels that you also see in one of the previous presentations. So again, showing the end-to-end application from the production of the renewable electricity to the use in the aircraft. And what's the exhaust of this aircraft? It's water. Zero emission, it's only water. And it's only a question of now getting to certification, which is planned for us in 2026. So you'll be able to fly these planes in 2027 with passengers in the US to be able to do your regional commutes, 500 nautical miles, zero emission. And what's the missing part is how do you bring the clean hydrogen from the production site to the airplane? Well, we're the Nespresso of the hydrogen. So we put the hydrogen in a modular approach, a modular capsule at the production site, so the liquid hydrogen, and we use existing intermodal freight network to be able to transport these capsules, plug them into the airport, plug them into the aircraft using existing cargo handling equipment, therefore making every airport hydrogen ready today. So no new infrastructure required to be able to bring this to life. So just where we are in the journey, we've got a big backlog. We've got $3 billion of backlog in terms of aircraft conversion and fuel service. And today we're deploying and going into service in 2026. We need the help of the whole ecosystem to be able to do that because, as you saw, it's from the production transportation. And one of the biggest, I'd say, difficulties we can talk about a little bit later in the discussion is how do you solve the chicken and egg issue of the hydrogen first or the aircraft first, and how do they both meet together? And that was it. Thank you very much.
They've got Neil's next, it looks like. Okay, so you should be able to click. There you are.
All right, good morning. I'm Neil Navin. I am the Chief Clean Fuels Officer of SoCalGas. SoCalGas is almost as old as the state of California. We've been around about 155 years. Our first product that we actually produced was actually hydrogen. We delivered hydrogen and methane in the form of town gas to California, Southern California, in 1867. Many people don't know that. So what's old is new again, in a sense. We are going back to something we had before. We deliver about 5% of the nation's natural gas today to end users. We're the largest natural gas utility in the Western Hemisphere, and we do some of that by delivering natural gas produced right here in Kern County to Californians. We have 8,000 people working on projects today, natural gas, tomorrow, carbon management, and hydrogen. So a few years ago, we decided to work in earnest to understand what is the value of a natural gas utility in a GHG neutral California, 2045, 2050. And what we did is we used many of the same energy modeling tools the state uses, but we said, well, what if we solve for that last 20 or 30%, the hard stuff? And further to that, we did a second study that said, well, what if we actually applied realistic reliability and resiliency tests to those models to say, what happens if it's really hot? Think about September 6th, 2022, or a very cold period. And what we found is that we need, much like an airplane, we need two engines. We need clean electrons and we need clean molecules to power California. And in fact, we can power California and transition the economy more reliably, more resiliently by actually introducing clean molecules, carbon management into an energy system that provides more resiliency and more reliability. Now, we're working on hydrogen, and I'll talk about that in a little bit. We have actually been working on hydrogen for about 20 years. In fact, we did some of the first power-to-gas work with UCI, University of California, Irvine, almost 20 years ago. Think green hydrogen. Now, we think hydrogen has many applications, including things like aviation. But we also recognize that heavy-duty transportation, dispatchable electric generation, which is a little counterintuitive. I think someone mentioned the Stanford study. And also heavy-duty industry. You know, when you think about California, especially Southern California, many people think about Hollywood. But more middle-class jobs, more union jobs come from manufacturing and industry in Southern California than anywhere else in the country. We are the largest concentration of manufacturing jobs anywhere in the United States. They all need clean electrons. They all need clean molecules. They need reliable and resilient energy. So we've been working on Angeles Link. Angeles Link is the idea that you would put together a hydrogen backbone system for California to move those molecules, those green molecules, clean molecules, to where they're needed. We've mentioned the ports. The ports needs a lot of energy. It should be clean energy. It should be green energy. It should be decarbonized over time. And ultimately, we should also think about the fact that all of this has the potential to clean the air. If we reduce the use of fossil fuels in some applications, we can actually clean the air in Southern California and provide significant benefits to our consumers, the people that consume our energy. Lastly, we really believe that the idea that we can decarbonize heavy-duty industries can also be coupled with the fact that distributed energy generation, the idea that we produce energy locally, is something that we really need to consider so that we can, in fact, reduce or minimize the electric transmission and distribution build-out, make it fit for purpose. So we are also working on things like our hydrogen innovation experience, the idea that you could produce hydrogen and use it in a microgrid, decarbonizing the electric system, but also decarbonizing the gas that we provide to consumers by blending hydrogen up to 20%. So we're very excited. We're very bullish. Again, we've invested in California for more than 150 years. Our product today, natural gas, has helped to displace coal. We think over time, natural gas coupled with renewable natural gas and hydrogen are going to provide a significant part of the energy transitions puzzle. So thank you.
Well, hello, everyone. My name is John Norman, and I'm the president of Hydrostor. We are a long-duration energy storage company, both a technology supplier as well as a developer of solutions that specifically use compressed air. But what I wanted to start off with, just given some of the discussion earlier, was maybe stating the obvious. Kern County has been an energy hub for more than 100 years. And given the passion, dedication, commitment of everyone I've seen in the room and the panels thus far, I am very confident it will continue to be an energy hub well into the future. And the foresight of this group, not only in realizing the importance of energy transition, the importance of oil and gas in that transition, and then the transition itself towards new types of technologies, things that, as Lorelei indicated, aren't just about the energy default, that actually do set the stage for the future. That's one of the reasons we're very committed to Kern County. And what I'd like to talk a bit more about is that I think it's obvious that oil and gas, renewables is the foundation of historically where Kern's been an energy hub. But it goes beyond even carbon capture and storage. Kern can really be a long-duration energy storage hub as well, which is really, really critical to California going forward, which I don't think is surprising to folks. So how do we do it? Well, what's neat about us is we're just really building on a precedent that's existed for quite some time on compressed air energy storage. So you're really just taking off-peak electricity, running it through a compressor, storing high-pressure air underground, and then running that air through a turbine when the grid needs it. It's quite well proven. What's neat about what we do specifically is that we can flexibly site our resources. We actually construct cavities out of hard rock, to Mike's point about the types of labor and materials that we need. And we also don't use an external heat source, although we can. We can use hydrogen, we can use natural gas, but we can also just use the heat from our compression system. And that's typically what we do. So we're a true storage resource. We store that and then put it back into the turbine to generate electricity. What's kind of neat about this is we're effectively a systems integrator, and we're really just integrating oil and gas process equipment along with mining to be part of the solution for the clean energy future over the longer term. So it's sort of using the same skill sets, same technologies, but deploying them in a different way that you can have this resource. What's really interesting to us is that Kern County itself is really, really well suited to our types of assets. In fact, we've been working for quite some time on developing our project in Kern, which is in southern Kern County near the town of Rosamond. And we're connecting into the Whirlwind substation. So we actually had a choice. We could have been in Kern County, we could have been outside Kern County, we're right near the border. We've intentionally chosen Kern County time and time again because it's a very supportive environment, very supportive planning environment, excellent focus on being an energy hub, and we want to continue to commit to that going forward. So just to close off on what we've been doing over the past couple of years, we are very committed to this project. It is a 50-year plus resource, in fact, probably much longer than that. It's almost indefinite infrastructure, so it's not just fly-by-the-night types of inputs that are being manufactured elsewhere. It's heavy infrastructure. We've been advancing our permitting very significantly to the point where we're now very advanced in that process, and we've already done all of our feed studies as well, in addition to achieving full deliverability of our electrons to provide capacity to the California grid. That's not a minor thing. In fact, when we were awarded that allocation, I think it was about 12% of the total allocated capacity in California. So this project alone is already becoming a critical piece of infrastructure for the entire state. Never mind the fact that we also have additional development pipeline focused on Kern County to build on our global pipeline as well. We're very advanced in Australia. We already have an operational asset in Ontario, Canada, and we're backed by Goldman Sachs. We're actually their global play on long-duration energy storage. So we're very much looking forward to committing more to Kern. This project alone, as you can see, is about $500 million of direct investment into the community, additional investment on top of that through the induced economic impact, and very, very significant on the labor force because we're infrastructure. We're not just importing stuff, we're actually building it domestically here. And there's about 2 million man-hours of jobs just associated with the construction of this asset, plus 40 to 50 ongoing jobs that interestingly are very similar to the jobs that run fossil-fired power plants. So this isn't the same as sort of transitioning to solar or wind, it's transitioning to the same turbo machinery that these operators are trained to operate. So we're very much looking forward to continuing to work with this entire group and community, and appreciate your time today.
There we go. Good morning, everybody. I'm Mike Simpson with AES. Many of you may know AES. We're a large independent power producer. We operate in quite a few countries around the world, and we obviously do a lot of work here in California. I'm going to talk just briefly about some more conventional, traditional renewable energy technologies, but I'm very pleased to be on this panel with folks doing incredibly innovative work in clean energy, and really honored to be with you all here today. So again, if you're not familiar with AES, we do work in quite a few places. We've got 5.1 gigawatts of clean energy projects operating today, and we're developing quite a bit more. I do want to highlight that we've got a close connection with Fluence, so I'm going to be talking a little bit about our energy storage work, which we do a lot of with Fluence, and I'll just move quickly through this. So if you want to talk more about the details, I look forward to connecting with you afterwards. In California in particular, we've been working here since 1989, doing a lot of different kinds of projects, both conventional energy as well as clean energy. We have over 1.5 gigawatts of solar, wind, and energy storage here. And in energy storage in particular, we do consider ourselves a leader in this area, first deploying energy storage on the grid about 15 years ago. And we continue to develop our technology and evolve how we're doing energy storage to make it safer, more cost-effective, of course, more reliable as a grid resource. Oops, that was backward. So I don't think we need to talk too much about the role of energy storage, but we're pursuing it because we know that, of course, there are high goals for deploying energy storage in California, but also this is a technology that's been proven, and ultimately we see energy storage as a key asset towards improving grid reliability. It's a flexible resource that can do a lot of different things if it's used right. And it can help enable clean energy and energy transition as other forms of energy evolve as well. Specifically, I'm here because we've been launching a new project over the past year, the Belfield Solar and Storage Project. It's planning for a gigawatt of solar, conventional PV solar generation, as well as 500 megawatts of energy storage. For a 4-hour duration to help support the variety of energy needs here in California. It's slated to, the first phase should be in operation by 2025, and the second phase in 2026. At peak, the construction should support about 1,000 jobs here in California. But I also want to look ahead, as I had on the slides there. Right now, pretty much all of our energy storage deployment is using lithium-ion technology, the same technology in the cell phone in your pocket. But as we look ahead, we know that there are other technologies that can help with this. We see the evolution towards lower costs, lower reliance on rare materials, and for both cost effectiveness as well as geopolitical stability. We see an increase in domestic supply. We see additional options for bulk storage, like potentially Hydrostor is looking at, yeah. And we also see a growth and diversity of the market services and applications, as well as just making this stuff work better, higher availability, higher reliability. We're pushing for all of that. And while we're deploying conventional technologies into Belfield, we know that the future in Kern County is going to rely on more of these concepts as well. Thank you very much.
Well, you all went way over the time, so the panel's over. No, we have 4 minutes. Okay, so in all seriousness, let's talk energy storage with you two first, Mike and John. Mike, you put up a graph. We've got 6 gigawatts installed in California. Stratogen report to Kaizo says we need 60 gigawatts of storage by 2045. Long duration energy storage. So I guess two-part question. Are batteries long duration, and how do we get to 60 gigawatts for both of you? Maybe if you could each address that.
Sure. Can batteries do long duration? I mean, batteries can definitely do long duration. I think that we're still studying some of the impacts of taking what is rated for a 4-hour duration battery and operating it over 24 hours or longer. We do that at some of our sites today. There are potentially some impacts to degradation and performance, but it can be done. Is it the most cost-effective way? I think the answer is no. In the next couple of years, I think we're going to have a lot of technology options that will enable much longer duration. To get to that scale, we're going to have to deal with the same kinds of things that have been talked about earlier with permitting, as well as technological advances. I guess I don't want to go too far. Maybe we can talk more at lunch.
Yeah, no. And it's not, it's definitely not either or. I mean, it's really all of the above. Unquestionably, 60 gigawatts is a big number, and it absolutely is required. Where we're really well suited is that we kind of operate similarly to a fossil plant. So as these things retire, because their natural life cycle they're retiring, we can actually flexibly locate where they are and operate very similarly. So it's really valuable on the grid that way. I think the key, though, is there does need to be the action, right? We talked about Sacramento and the aggressive goals, but where's the action? There need to be clear targets for this that allow the industry to respond. We've even been caught up. We had the foresight to develop early enough that we were part and deliverable on the CAISO queue, but that caused us gating issues with our permitting process. Kern County's actually been very helpful at trying to help us navigate that. But it does cause hiccups, and then we need to optimize our location depending on where we are. We know this is proceeding. This project will be in place by the end of the decade, unquestionably, but there's so much lead time required for all these other resources. So the time for action is now.
Great. Arnaud, let me ask you, California consumes more jet fuel than any other state. How much jet fuel can you replace?
So with the regional aviation, it's 7% of the aviation that's considered, and the goal is really to demonstrate to the Airbus, to the Boeing, to the aircraft manufacturers that there's nothing preventing the move to the next step, which is the single aisle, which is the 737 and the A320 family, which is 60% of the emissions of the aviation industry. So that's the ultimate goal that we have. And go ahead.
Oh, no, I was going to say, sorry to move you along. We're down to like 120 here. Neil, talk to me about pipeline retrofits, because we see in the oil and gas community, we see Exxon saying, hey, we can't do this replacement in Santa Barbara. Just not going to happen. We're going to have to repair it. What is that like to convert natural gas pipeline to hydrogen?
Yeah, so as brief as answer as possible. So there's two answers to that. One is, if we want to move the amount of hydrogen that we think we'll need by mid-century, we'll probably need to build new pipelines, undoubtedly. That is the thesis for our Angeles Link. But if you look to Europe, Europe has been instructive in all sorts of ways. The idea that Europe became dependent on Russian natural gas and very quickly had to figure out the energy transition and energy reliability on the fly is instructive in that they have gone very deeply into understanding how can they repurpose their pipeline systems. The European Hydrogen Backbone project, which is a project across much of Europe and many operators, would suggest that they believe they can reuse about 70% of their current assets to move up 100% pure hydrogen. I think in California, we are the 4th largest economy in the world unto ourselves. We at SoCalGas, we're looking at blending renewable natural gas, biogas, produced from the San Joaquin Valley with hydrogen, up to about 20%. Again, that allows us to leverage our existing resources like natural gas and gradually decarbonize. But the idea that we can use the existing pipelines, but also the right-of-ways, then those are really, really important. It's hard to build new energy infrastructure in California, and it's important to connect, I think as was said earlier, those places where we know renewables are going to be developed, high solar irradiance, good wind. We need to connect those electrons. We need to maximize the use of those renewables, and we're probably going to need to produce hydrogen there and move it in pipelines to the places where it needs to get used.
Thank you. I wish we had more time. I think one way to wrap this up that I'd like to comment is, this is an energy renaissance. We need everybody. We need oil, gas, hydrogen, batteries, long duration. We need it all in an effort to decarbonize. And most importantly, I think for all of us here, we need to get involved at CSUB, at Taft College, at UCSB. We've got a UCSB professor in our energy and science group that wants to study the economic impact of this oil shutdown. It's going to be phenomenal. Berkeley, we need to be at the college campuses because these are the students that are going to be the future policymakers. And if we can educate them on the truth of how difficult it is as developers to do all of this, we're going to be in a much better place in 2045 because we will have folks that know how to permit and that know the urgency of what we have to do. And I think that's a big missing ingredient right now. So thank you all for your participation in the panel. Hopefully we didn't take up too much time, Richard.